Now we will take a look at relatively some new questions, right? So I'm going to choose some problems starting with, yeah, 2018. So 2018 we have a question related to inverse functions like this. So they want you to show that, right? So 2018, by the way, they want you to show that 2 tan inverse 1 over 3 and then plus tan inverse 4 over 3 is equal to pi over 2. So we need to show that. Okay, so we have to show that. Now you might notice some similarities between one of the questions we did from the tut and then this one. Okay, so we can use some strategies from there. I want you guys to pause the video and then try this question on your own and then come back. Then take 10 minutes to try it and then come back and check it how it goes. So as we got something like this, I hope you guys have tried now. What will happen is we can write this, this tan inverse thing. No, we can write the tan inverse 3 one third as alpha, and then the tan inverse of 4 over 3 we can consider it to be basically beta. So technically what we have here is that 2 alpha plus beta. Okay, so that's what we have, and I will consider this is equal to something. We will so we will consider this to be something like theta, right? So we'll consider it to be theta like that. Now what is going on is I'm going to take tan on both sides. So if I take tan on both sides, we can have tan 2 alpha plus beta equals to, this is tan theta. Now if you notice here, this is going to be tan 2 alpha plus tan beta divided by 1 minus, this is tan 2 alpha times tan beta equals to tan theta. So we have to somehow show that the tan theta, right, becomes undefined. That's the idea. So this tan 2 alpha is there now. So tan 2 alpha, I can write it as 2 into tan alpha divided by 1 minus tan squared alpha. Okay, so we can write it like that. So this I will simplify now. So this is 2. As you can see, tan alpha is going to be 1/3. 1 minus 1 over 9 it turns out to become. So I will write the rest of this one here. So this is going to be 2 over 3 divided by, so this is 9 minus 1 is 8 over 3, 8 over 9 actually. So these two cancel off to a 3, 6 over 8, which you can write as 3 over 4. So you can see that tan 2 alpha becomes 3 over 4. So I will substitute it back here. Okay, so I'll say this is 1, this is 2. So we can put the 2 into the 1. So when I do that, I'm putting it here. So this is 3 over 4 and then 4 over 3 because tan beta is 4 over 3. And then here we have 1 minus 3 over 4 into 4 over 3. And then this is going to be equal to tan theta. As you can see, this is undefined. So this sort of a scenario happens. So when you have odd multiplications of 90 plus pi over 2, so theta is equal to pi over 2 because that is where the range of the angles of theta happens to be. So that is very simple. So this is 2018 A levels problem related to what we call as inverse function problems. Okay, and next we will look at another question. Always remember, when you are looking at these videos, always pause, try the problems yourself, right? And then look at how the things are done. Okay, so otherwise it's going to be a waste of time for you, not me, for you. So this is 2019 A levels. So in this one they are asking us to solve. Earlier one was show that this is solve. So they say here 2 tan inverse of x plus here we have tan inverse of x plus 1 equals to pi over 2, right? So let's see what we need to do. uh, so you can use the same strategy as earlier ones. Right, so you can literally see, like, some similarities are there from the last time. Yes, so I can say this is 2 alpha and then say this is beta, this is equal to pi over 2, and I could take the beta to the other side. Okay, so this might make some of our work a little easy. And then I can take tan from here, take tan from both sides. And notice that this is going to be 2 tan alpha over 1 minus tan squared alpha. This is going to be technically cot beta. This is cot beta. So what is going to happen is that it's clear that I can put whatever tan alpha here. So tan alpha is technically x. So that is 2x 1 minus this is x squared. And cot beta in the sense it's a reciprocal of the tan, so it's going to be 1 over x plus 1. Okay, so it's 1 over x plus 1. Now, so what can we do here? We can cross multiply things. So that's going to be 2x into x plus 1, and then this 1 minus x squared over to the other side like this, and I can take everything to one of the sides. So I'll bring these things here. So I have 2x x plus 1 and then minus uh, I can write plus we'll say x squared minus 1 equal to 0. So here you can see x plus 1 is a common factor to x squared plus 1 because of difference of two squares. Okay, so that is, I can write the x squared minus 1. I can write x squared minus 1 as x plus 1 into x minus 1. Okay, so x plus 1 over here is a common factor. Bring that out. You will be getting x plus 1 here, 2x, and then this is going to be x minus 1 equal to 0. So either x is going to be equal to minus 1, or else what will happen is x is going to be equal to 1 over 3. Now we need to see if x can be equal to minus 1. Is it valid even? So if that's the case, this is going to be 0, right? It's problematic over here itself. But let's take a look. So that will be 0. So tan inverse of 0 is no issue. Yeah, so no issues. It can happen. Sorry. But I don't think this is the minus 1 will actually satisfy the equation. Let's check. So if you put here, that's 0, and then this is going to be minus 1. So minus 1 in the sense that's going to be minus pi over 2. So this is not satisfying. Okay, so it doesn't satisfy. Also, the reason is over here. It can't be. Okay, so we can't divide anything. So this is your correct answer. X equals 1/3. Okay, so always check out for possibilities of a solution as well, because that is how you should do maths. And now we will work on another one more question. This is from 2020. So on 2020, they had given a question like this. This is a little weird, but from the previous questions we did. So it's tan inverse of cos squared x, and then plus this is tan inverse of sin x is equal to pi over 4, which are similar to the questions in the tute, however, right? So what can we do in this one? Is I can say this is, consider this entire angle is alpha, this entire angle is beta, that's equal to pi over 4. And then I can take tan on both sides like this. And notice when I do so, so tan pi over 4 is equal to 1. This is equal to 1. And I can expand this thing into tan alpha, tan beta, 1 minus tan alpha, tan beta. Then tan alpha is actually equal to cos squared x. Cos squared x, yes. And tan beta is equal to sin x. 1 minus, this is going to be cos squared x into sin x equal to 1. So rest of the things I'll solve like this. So you can see here, I can cross multiply the bottom part to the other side. So I will have cos squared x plus sin x equal to 1 minus cos squared x sin x. Okay, so you can write it like that. Is this in the frame? Yes, it is in the frame. Okay. Then we can't do things when you have sine and cos both. So I have the chance to convert the cos into technically sine. So I can write cos squared x as 1 minus sine squared x. And here 1 minus, this is 1 minus sine squared x into sine x, right? So I need to open the bracket. So this is going to be 1. Oh, by the way, I can cancel this one to the other side's 1 as well. So nice. And take this to the other side at once. We'll do so. So what will happen is, no, we'll keep these things. Sine squared x, sine x. Over here, you will be getting minus sine x. Minus minus plus sine cube x. We'll do one by one. Then take these two things to the other side. So when I take to the other side, I will have sine cube x on the other side. You can see that. And then this sine squared x goes to the other side and becomes plus sine squared x. And this sine x goes to the other side, becomes a minus sine x, and adds with that other minus sine x to become minus 2 sine x. So we have 0 here. Now what is going on is we can take sine x out as a common factor. So we have here sine squared x, sine x minus 2. Now we can take factors of this thing. So I have sine x plus 2, and then sine x minus 1. So either sine x have to be 0 or sine x need to be minus 2. This is impossible because remember, we know that sine x has to be larger than or equal to minus 1 and less than or equal to 1. It can't be minus 2. It's impossible. So we ignore that case. Or else sine x can be equal to 1. So these are possible answers. Now, next, what are we going to do is we are going to solve them from here. So what we have next is we need to look for a solution for sine x equal to 0. So this part is, I think I can write up to here. So sine x equals 0, I can find a solution. So I can write, so sine x equals sine 0. So then x is equal to n pi plus minus 1 to the power of n 0. So that means x equals to n pi is a correct solution. So x equals n pi is a correct solution. Then after that we need to look for a solution for sine x equals 1. So sine x equals 1 is happening when sine equals to pi over 2, sine pi over 2. So then x is equal to n pi plus minus 1 to the power of n pi over 2. So that calls the answer for 2020 A levels question. Okay, so I hope you guys solved it on your own, at least attempted it for some time before looking at how I solved the thing. So I want you guys to try the questions on 2021. 2021 we don't have a question. I'll no inverse function problem is not there. I will send a problem, you guys can work it out. Okay, so that's that for this. We'll be having a power cut in a few minutes, so I need to upload this before that happens.